So, to the last but not least part of this video. It's kind of emotional, right? We come a long way. We start from the differential equation on the board, and then we make an educated guess, and then eventually we come to something beautiful. We reduced it, and then we find a differential equation. We find f. But it's not the purpose of this video right now you're watching. The purpose of this video is I want to digest into Dr. Mehmet's intelligence and brilliance. I would attempt to see how do he guess this, like how can he come up with the alpha. So what do I mean by that? Let me actually mean a new section. Do you remember this equation? Cotangent theta. Okay, I need to make sure. I'm gonna write like this. Okay, plus 2 alpha equals 0. Dr. Matters come up and say, he come up with the answer immediately. He say alpha equal to sine theta square, and then when he let me denote this equation 9. And then when he plug it to equation 9, it makes sense. It correct. It use 0. So yeah, alpha is sine square. But actually today I would attempt to explore his brain, explore his thinking process and see how can he come up with such a beautiful result. So I think Dr. Matters did this way. I think first he assumed that alpha equal to a times sine theta to the power b times cos theta to the power of c. Okay, and a, b, c are constant. Okay. Now a, b, c are constant, right? Okay. The goal is to substitute this yellow highlight into the equation 9, and then do some guess checking, and then you can find a, b, c. And remember, a is not 0. A is not 0, because if a is 0, alpha equals 0. 0 is called, it's a generic solution, something trivial solution, and we don't want to get a trivial solution in this case. We want to get a concrete function. Okay, so let's go ahead and do the most headache thing in the world is taking the damn derivative. Now let's start with alpha prime. What is that equal to? A is a constant. I'm gonna put it out. Sine b. At first, I'm gonna calculate the derivative of sine theta to the power b. It will be b times sine theta to the power b minus 1 times cos theta according to chain rule. And then I'm gonna attempt to take the derivative, and then don't forget to times cosine theta again, because let me actually highlight this. Yeah, because oh look, it turned green. So yellow plus blue equal green. Exactly, I just discovered it, guys. It's so cool. All right, and then you find the derivative of cos theta to the power of c, right? So what do we, c times cos theta to the power of c minus 1 times, yes, if c equal to anyway, never mind. Okay, cool. Times negative sine theta, because chain rule, and then times sine theta to the power of b. Yay, let's see if we can simplify this. Now I'm gonna go ahead and I'm gonna write alpha prime right here, so have more space. Okay, I'm gonna write the rule is like this. I'm gonna sign sine first, cosine, and then the coefficient. So this is sine theta to the power b minus 1 times cos theta to the power of c plus 1 times b plus, okay, negative, I'm gonna disregard negative for a bit. Sine theta to the power of b plus 1 times cos theta to the power of c minus 1 times negative c, right? You agree with me? Okay. And then I'm gonna expand it. Go to alpha time. Yeah, I'm gonna expand it to, okay, I'm gonna try to blue so that I won't sure. So it will be sine theta to the b minus 1 times cos theta to the power of c plus 1 times a times b. Remember, guys, abc is a constant and a is a constant. A is not 0, okay? A cannot be 0. All right, b plus 1 times cos theta of c minus 1, and then you times a2, so times negative ac. All right, so cool. That's alpha prime. Oh my god. Okay, I'm gonna go ahead and times alpha prime to cotangent of theta, so that later we don't have to do it. So alpha prime times cotangent of theta, and we all know that cotangent of theta is cos theta over sine theta. So it would be, if you times them here, sine would lower that one more power, so b minus 2 times cos will increase to 1 power, so c plus 2 times a times b, or times ab, plus sine will lower to 1 power, so sine phi to power b times cos will be lower to 1 power, so cos theta to power c minus 2 times negative ac. Okay, I'm gonna highlight it yellow. Okay, this is okay, I'm gonna write 2 alpha as well, so later we just add them together. You see what I'm saying? 2 alpha equal to sine theta b cos theta c times a 2a. Okay, I'm gonna highlight that. Okay. All right. We have this term, we have that term, and now we're gonna find the beast, alpha the prime. Oh my god, you say, oh no, it's so scary. I understand, dude, it was scary for me too. Honestly, when I did it, I cried. Like, I cry a lot, man. Like, oh man, like I cry so much. But let me actually pause for like 2 seconds, okay? Let me pause. I'm gonna go ahead and pause for 2 seconds. Okay, take a deep breath. Guys, learn how to breathe. Breathing is very, very important. Like, breathing is the essence of life, you know, like, it is so important that you know, what you would call it. It is so important that people nowadays, like, they just learn to breathe not only through yoga, like apparently to testing and to running, to meditating, and to like just deep breath, you know, like very, very important. I think this is part 4. So yeah, I mean, learn how to do that. It is like crucial to your health, and just don't give up. Never, ever give up. Okay. All right, now let's find a beast. Without first say, let's find a beast. Okay. Actually, the beast not bad. Okay. Look at alpha prime. So now alpha 2 prime is alpha prime, right? So what would be? Okay. So AB, I'm gonna put this. I'm gonna put aside. What is it we have inside? We have b minus 1 times sine theta times b minus 2, and then times cos theta. Okay, it's gonna be long. Bear with me. Don't be afraid. Don't be afraid. I understand, this is kind of insane. And then the next term, we didn't take the derivative. We still have it as cos theta to the c power c plus 1. For the sake of this, I'm gonna write like this. So I'm gonna write in a novel way, like to make sure it's clear for y'all. Okay. Okay, so that I hope we won't get a vertical after this. And then you take the derivative of a second term, which is c plus 1 times cos theta to the power of c, right? To the power of c. And then chain rule kick in, the derivative of cosine theta is negative sine theta. And then I just want to make sure everything is correct. Okay, and then you times the term is sine d to the power of b minus 1. Yeah, b minus 1. Okay, this is the first term, okay? And then we have to add the second term. The second term, which is, I can pull negative AC outside, cool. And then what do we have inside? I'm going to take the derivative of each thing again. What do we have? We have, what do you call it? The, oh, God. Oh, my God. Oh, God. All right. Where were we? I'm kind of lost, actually. Man, kudos to anyone trying to follow with me through this video. Okay, sine phi b plus 1 first. So it would be b times sine theta of b, right? Oh, no. No way. There's no way. Okay, derivative of sine phi to the power b plus 1 is, oh my god, b plus 1 times sine theta to the power of b times cos theta, apparently. All right, because of chain rule, I just want to make sure. And then you times to cos theta to the power of c minus 1. Yeah, Dr. Meredith is tough. Like, guessing this is, and then you and then you take on this term cos t to the power of c minus 1. So it would be c minus 1 times cos theta to the power of c minus 2 times negative sine theta. Okay, and then you times sine theta b plus 1, because yeah, sine theta to the power of p plus 1. Guys, this is, you have to be very careful with this, okay? Okay, now you simplify it. Okay, well, let's see what we can simplify. Again, the goal is like this. You rewrite the coefficient of sine first. Sine phi to the power of b minus 2. And then coefficient of cosine theta, this is c plus 2. Then b minus 1 plus, sine. I'm gonna disregard the negative sign for now. I'm gonna return layer, so it'd be sine theta to the power of b times cos theta to the power of c, and then times negative c minus 1. Okay, because you times negative 1 here. Okay, let me actually use the arrow to demonstrate to you guys. Times negative 1, I'm gonna put it here. Okay, does it make sense? And then the term negative AC is gonna be, oh my god, you see, okay, so sine first, the rule sine first, b, and then cosine, in this case is c times b plus 1, cool, and then plus sine first, the rule symbol, this is the same. I'm gonna put this negative sign here, I'm gonna disregard it, so sine theta to the power of b plus 2 times this, guys, this is, you have to be very careful, because theta c minus 2 times 1 minus c. Okay, you just flip it. We're gonna have a negative sign, something, just flip it. Okay, and now you expand it. Okay, so alright, prime will equal to, okay, so sine theta to the power of b minus 2 cos theta c plus 2 times ab times b minus 1 is ab squared minus ab. Okay, and then plus sine theta to the power of b times cos theta to the power of c times negative abc minus ab. Okay, and then plus sine theta to the power of b times cos theta to the power of c times negative ABC minus AC plus sine theta to the power of b plus 2 times, man, Dr. Matheris, he's a hero, c minus 2 to the power of c minus 2, negative AC times 1 is negative AC times c is plus AC squared. It is, ladies and gentlemen, this is our alpha prime. Now, alpha prime plus minus this times 2 alpha equals 0, and then you have to construct it. Okay, so what will we have? Okay, I'm gonna, should I split the video? Yeah, I'm gonna split the video.